Alrighty folks, I'm going to start a new little channel because a lot of the times it's easier to answer this kind of stuff with a video. So one of my viewers sent me a question about the FLSun Q5. I'm going to show you the video of the problem he's encountering, and then I'm going to explain what the probable issues are and how to fix them. So you see that arm's not moving. Those two home normally. And we also saw it was printing in the beginning of the video. And now he's going to try to start another print, and we're going to see an obvious problem with doing that. So it just homed those two, and it didn't home that one. And now it's making a whole lot of grinding noises. So let's go over why it did that. Okay, why it did that is actually pretty easy. Sorry for the crude setup here. I wasn't prepared to do a little professional go at this. So I have a little glass here to hold the camera up. Okay, so remember what I said in one of my older videos. 3D printers are dumb, deaf, and blind. Okay, they have basically no ability to sense, no ability to scan or hear or see, etc. A 3D printer depends on having a fixed 0 point and then following explicit movement commands from there. So one of the things I showed you was that if I want to draw a circle, I say draw a circle on your hand. Well, I draw a circle on my hand, no big deal, right? 3D printer can't do that. Now let's do a square, that's better. Okay, so a 3D printer, I can tell it go to 0, 0, 0. So it's going to go click, 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 click. Those are your 3 end stop switches. That's 0, 0, 0. It's up to you to make sure the 0, 0, 0 of the kinematics matches the 0, 0, 0 of the bed, and that the two planes are parallel. Okay? So then draw a square. Printers can't draw squares. That's not how they work. What the printer can do is say, move the X motor this number of steps. Move the Y motor this number of steps. Now, move the X motor this far, move the Y motor this far, move the X motor this far, move the Y motor this far. Now, move the Z motor this far. Now, move the X motor, Y motor, X motor, Y motor, Z motor. That's all a 3D printer can do. Okay, that's why first level bed leveling is so important. Because in order for the part to stick to the bed, the printer has to know where 0, 0, 0 is. And you have to make sure that the 0, 0, 0 of the virtual plane that's made up of the kinematics of the printer matches the physical plane of the print bed. So a Delta printer is a little different. With a Cartesian regular 3D printer, 0, 0, 0 is on the bed. But with a Delta printer, you have a set of towers. So this is the top of the printer. And at the top of the printer, you have 3 end stop switches, 1 for each arm. A Delta printer doesn't really have an X, Y, Z. Z is all the motors up or down, but X is a mathematical dance of all 3 motors. So with a Delta printer, there is no XY plane like there is on a Cartesian plane. It doesn't exist. There isn't an XY plane. What there is a mathematically generated XY plane that is virtual based on the motion of all 3 motors. So for a Delta printer, you're printing down here, but you're homing up here because you're using 3 arms that move up and down, and you can't really home the arms down because it's a Delta, so the arms are at an angle. So the carriage, arm carriage, can't go all the way down. It's going to come down like this and be at an angle. So what they do is they put the 3 end stop switches at the top. The printer goes to the top and goes click, 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 and it homes all 3 motors. And now, because you had previously defined the 0, 0, 0 of the bed, it then goes from that point where you define 0, and it moves up to home and says, okay, how many steps for each motor? Now it knows exactly how far this is from this. So when you tell the printer to print, it homes, and then it moves down that pre-programmed number of steps to get to the bed and begins printing. In his case here, the problem is a limit switch. One of the limit switches isn't working. Why, I don't know yet, but I can help diagnose that. You can tell this is the case because in the beginning you see the printers printing. So we know the problem is not the stepper motors. Clearly the stepper motors are working as the printer is able to move all 3 in order to navigate and print. So we know the stepper motors are working fine. Now, one trick you can see is that when you home a printer and you tell it to home, it brings the X over to its home switch. It brings the Y over to its home switch. And if you do it, start up an enter 3, it goes tick tick, and then the Y goes tick tick, and then the Z goes tick tick. It's moving to all 3 positions to get to 0 0 0. Well, in this case, you see, we know that motor can move, but it's not. So why would a motor not move when commanded to move? Well, what's the stop command for a home? Contact with the limit switch. It's going to move, and it's going to keep on moving until it hits that limit switch or until it hits some other internal limit that's programmed into it to keep it from going forever, if there is one. It might just go forever until it hits that limit switch. If you were to take the belt off of one of those motors, that motor may just keep going and going and going until an internal timeout is reached, or it touches a limit switch. That's why you can test your limit switches by telling the printer to home, being careful to watch where your finger goes, and you can actually go in there and go click and hit the switch, and you'll see the motor stops wherever it is, even though it hasn't reached home. Well, what's happening on his printer is it thinks it's already at home. So what happens if you're already at home? You stop moving. Okay, so it thinks that that one arm that's not moving is already there. So it doesn't move. Now, why does it do the grinding when it moves down? Remember, the printer is dumb, deaf, and blind. It has no idea where that arm is, and it has no idea where the bed is. The only thing it knows is when the arm trips the switch, which it thinks it already has, and then it knows the pre-programmed distance to move those arms to bring that effector head down to the bed. So let's call it 200 millimeters. I don't know what it is. Let's call it 200 millimeters. So that was a bad move. I was going to use the glass as a demonstration tool, and it's what's holding up the phone. Duh. So let's say we have to move the effector arm from here to here. So home, go up to the top, click, click, move a predetermined distance down. But what if you're here? Well, it doesn't know it's here. Remember, the printer is dumb, deaf, and blind. It thinks the arm is up here. It cannot sense the arm. It does not know the arm is down here. It thinks it's up here. So it's still going to attempt to move that arm the predetermined distance down, which is 200 millimeters. And because it's 100 millimeters, it's going to move it down 100 millimeters, and then it's going to hit the bed, and it doesn't know that. It has no way of knowing that the arm hit the bed. So it's going to keep trying to push the arm the other pre-programmed 100 millimeters until it's told that stepper motor to turn the exact number of times it thinks it's supposed to turn. And then, of course, the printer is all screwy at the bottom because now the arms are out of position. You know, because that one arm pushed the other arms to the side because it was not moving in line. It kept, instead of going down the number of millimeters and stopping, it kept going because it started from a point that was lower. So the problem is with the limit switch. The first thing you're going to do is you're going to open up the top of the printer. There's a bunch of bolts on the top of the printer, and you can pull that cover off. And inside, I'll use a piece of paper here, you're going to have 3 little switches. Okay, these switches look something like this. So it looks something like this. Okay, now normally there'd be a little lever arm, but on the Q5 it's actually a little peg. If you look up there, there's a little red peg, and that little red peg gets pushed when the printer gets to the top, which depresses the little button on the switch. Okay, now these switches come in 2 versions. You have what's called NO and NC. That is normally open and normally closed. Think of it as 2 electrical wires. Okay, when you connect the 2 wires, you are allowing current to flow through the 2 wires. That's called closed. When you break the connection, that's called open. So normally open is a switch that is open, no voltage goes through, and when you depress the switch, it's closed and allows voltage to go through. If you have a switch that's normally closed, the switch is always closed. So in the off state, it is closed. Voltage is allowed to go through. And when you depress the switch, you're actually breaking the connection, no voltage. So the first thing you need to do is determine, do those switches have 2 or 3 contacts? Because the way this works is the center contact is common. One of these is normally open and one of these is normally closed. That's right, the switch has 3 contacts. It is a dual mode switch. Now his may only have 2 contacts. I don't know. I didn't look at the switches on the FLSun, but you'll know immediately when you open it. If there are 3 contacts, then the switch is dual mode. Normally closed or normally open. I don't know which one it is. I'm guessing. So the way you figure that out is you look at the other switches. If the other switches have the wires here, and that switch has the wires here, well, your problem is easy. Take this wire and move it over here. Make it like the other 2. If they are all the same, and or they only have 2 contacts, which means they're all the same, polarity doesn't matter, then you need to test them. So what you do is you put a meter on those 2 contacts of one of the switches that does work. Okay? You put your meter in continuity mode. So if you have like a little meter, you'll see a symbol on it. That, something like that. See that one with the little bell? The little like speaker icon there? Okay, that indicates continuity mode. Basically, it's testing beep, beep. Okay, when it's closed, beep, you get a tone because the meter is actually putting a small voltage through the 2 probes. And if you touch the probes, beep, 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 they work. You have continuity. Okay, that's why when you put a meter in continuity mode, the first thing you do is you touch the probes together to make sure the meter is working. When you touch them, it beeps. When you pull them apart, it doesn't beep. Well, put those probes to the switch. If the switch is normally closed, it will beep when you touch it. If the switch is normally open, it'll do nothing when you touch it. Now what you do is you take your finger. It's going to be a little hard. This is where those little gripper test probes come in handy, the little latch-on probes. Now take your finger or have somebody else, or use the arm for the printer. Push the switch. Make the switch click. Now put the meter to it again. It should be the inverse of whatever you got when the switch was not depressed. So if your switch was open, now it should be closed. If your switch was closed, now it will be open. Okay? Now, put your meter to the suspect switch. Make sure it does the same thing. If the other switch was normally open, this switch should also be normally opened if nothing is pressing the button. Now, press the button, see if it changes. Okay? If it's inverted, then your switch is either wired backwards or you have a bad switch, meaning the switch they gave you a normally closed when you should have a normally open. Okay? That's usually the case when you have a 3-wire switch. You just switch the 2 wires. Now, what if you do not get continuity, or it's open no matter whether you depress it or not, or it's closed no matter whether you depress it or not, meaning it beeps either time or it doesn't beep either time? Well, that means you got a bad switch. Now, you want to verify this first. Easy way to verify that is to swap switches. Okay? You don't have to physically move the switches. If the wires are long enough, you can actually swap the wires. And if you swap the, yeah, you want to be careful doing that. No, because then the wrong arm is going to hit the wrong switch and you'll get weird things. So if you can, if it looks easy, swap the switches. If you swap the switches, keeping the wires where they belong, the problem should move. So if Tower 1, the one in the video, was not moving when you told it to home, and Tower 2 was moving, if you swap Tower 1 and Tower 2 switches, now Tower 1, the first tower that wasn't working, should begin to move correctly, and Tower 2 should now fail to move when you tell it to home. Okay? If that happens, good. You've just confirmed you have a bad switch, and you've tested it, and you've verified it. First thing, look on Amazon, see if you can find a replacement switch. Okay? Don't worry about getting one from the manufacturer. We'll do that in a second. Just, if you can get one off of Amazon, do it, because you'll get your printer functional more quickly. Also, send an email to FLSun. Explain to them, hey, I bought your new Q5 printer. One of the tower arms isn't homing when I tell it to home. It works, but it doesn't home when I tell it to home, so the arm is out of position. I've tested the switch. The switch tests bad. I've flipped the switches, and the problem moved when I flipped the switches to another arm. I've confirmed that the switch is actually bad. They will send you a new switch. I highly doubt they're going to complain. I mean, you did the work necessary to verify the problem. The switch cost them a few pennies. They'll mail you a new switch. But it's going to take like a month and a half. So if you can get one off Amazon, do that. And then you'll have a spare switch from FLSun. Because, I mean, justifiably, they should replace the switch. Now, also, you can use the printer in the meantime. The printer only needs the end stop switch for the homing process. Once it does the homing process, everything else is mathematical. So, manually move the arm up. That's it. when you want to print something, just grab the carriage and push it up until it clicks the switch. Okay? When you let it go, make sure it stays. If it drops, after the printer, you might want to hold it up there until the printer, does its homing and then let it go. Okay? When it reaches temperature and the arms begin to move, and then let it go, and the printer should work fine. You won't have any problems until you get a replacement switch. But there you go. That is the reason he was having a problem with his Q5, and it is most likely a end stop switch that's the problem. That's how you diagnose it, and that's how you confirm the diagnosis and take care of it. Also, check for loose wires. It could just be a loose wire to the brain board. Okay? If you swap the switches and the problem still persists on the first arm, well, then the problem is either at the brain board or at the wire going to the brain board. Okay? Because you moved it, the other arm still works. That confirms the switch is okay, and this arm still doesn't work, which means the switch is good and it's not the switch causing the problem, which means it's the wire going to the brain board. There's a short somewhere, they're touching, and it's normally open and now it's normally closed, something like that. That's it. If you have any questions, ask down below.